We'll proceed in calculation of flux in calculus. Flux is calculation of flux in calculus. So calculus flux is nothing but surface integral. Repeatedly we have seen that flux is nothing but surface integral. So if I have a okay, so that also we have talked that if I have a if I have a surface and this is xy plane, if the surface is fxy function over x and y, if this is fxy, then its integral along xy plane, integral along xy plane. So if I have a surface fxy and its integral along xy plane means volume. If I have a fx, I have a curve fx and this is x-axis and there is a curve, then integral of this curve along x-axis is the underneath area. Like that, if I have a surface and integration of this surface along xy plane will give me the volume under the surface. Okay, so surface integral gives volume as per the calculus also. We have seen many things. Now consider that if I have a surface and there is a vector field, then what is integral of this vector field along the surface? If I talk in many other ways, okay, so if I talk in other ways, okay, so if I talk in other ways also, okay, so this will give kind of okay, so if there is a surface and there is a vector, then area integral, surface area integral. If there is a vector, like there is a velocity vector and it is 2 meter per second and there is an area which is 4 meter square, then surface integral is nothing but the vector that is 2 meter per second into the area. If it is 4, it is 2, then it is 8 meter cube per second. We have talked about it. If I have a velocity vector, if I have a velocity vector and then there is an area, then velocity vector integral along the area is the volume that is coming out of the area. We have given example of water. So if there is a water with velocity v and there is an area, it is crossing the area, then how much volume of water that is coming out of the surface? If area is a and velocity of water is v, then v into a meter cube per second, that is the volume of water that is coming out of this surface. So this is called surface integral. Since there is a water, it will have a direction. So rather than saying 2 meter per second, I can denote it in a vector 2i, 2i meter per second or 2i plus 3j. Then water is in this direction. If this is x-axis, this is y-axis, then water is in this direction 2i plus 3j. Then area has a vector along the I-axis. Then 2i dot area vector. The vector both side area vector can be flat, area vector can be like this, where these are the surface of the area. How much water is coming out of the full surface? Then area vector will be different at different locations. Algebraic vector, vector field. So if I denote the velocity vector as capital F, then capital F dot dA vector along the surface is integration along the surface is the kind of surface integral. How to calculate now what we saw, not only this one, we saw further to it. So if I have a vector field capital F dot small dA vector, that is the surface integral. If this is a surface integral, what is line integral? Capital F vector dot dr vector. That is line integral. No, 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 I don't want vector vector. My vector, consider my vector is in along I axis only. That is a algebraic equation. The dot will go away because your r vector is along I axis only. If you think that way, then your function dx, simple integration. If you see surface integral, then a vector, if it is xy plane, then dx dy. Dot product will go away if the force, the if this is xy plane, then its direction is along k axis. If you take surface and its direction is all, if you take a vector field and its direction is also along, okay, if you take a vector field, its direction is also along k vector. This is what I think so. Then it will be f, whatever algebraic equation is dA, dx, dy. So these are the special term. In generic term, it is capital F vector dot dA vector. Now capital F vector generally it will be given. What about dA vector? That is always a question. Like consider I have a hemisphere. Okay, so consider that I have a hemisphere. This is a sphere. If I cut it down from the half, top half is hemisphere. Now hemisphere is kept on the xy plane, centered at the origin, and there is a vector field that is zk. Vector field is zk. Then what is surface integral along the hemisphere? If there is a water that is going in z direction, then how much water, if I cut it into half, then how much water is coming out of this surface? Volume per second, whereas the water velocity is zk and the surface is hemisphere. Then now we have seen, now the idea comes is that calculation complexity lies in dA vector. If I have different kind of surfaces, then how I can calculate the area vector? If I have a if I have, if this is xy plane, this is surface. If the surface is parallel to xy plane, then the surface, the surface area vector is along k axis. This is x, this is y, and this is z. If surface is parallel to xy plane, then the if surface is parallel to xy plane, then area vector will be perpendicular to the it. So this is area vector of the surface. This surface is oriented surface. Oriented surface means that other one side the area vector is like this, whereas other side area vector is like this. Both surfaces are oriented in own way. Oriented means one side, if I take normal vector and if I try other side, then there will be sharp change. Two surfaces, that is oriented surface. So if I have oriented surface, if I have oriented surface, if I have oriented surface, then consider this direction is along k axis. I mean, if I have xy plane and there is a surface, then surface has a direction k. Whatever the surface equation is, k vector is the direction. So dA vector is along the k axis. Now, now we are in discussion that there are two ways to calculate the area vector. The main concept that comes into the picture is calculation of area vector. How we calculate the area vector. That is the biggest challenge we get. So we saw there are two ways to calculate the area vector. One is primitive calculus that we use in Cartesian coordinate, and one is modern calculus where we do it in cylindrical and spherical coordinate system, which is nothing but considering a delta A, small a patch, small a patch. If I take a small a patch, then through that, like this is a sphere. If I take a small area patch here, then if I calculate that a delta A, and then whatever is the perpendicular vector is, if I calculate unit vector of it, then delta A into this unit vector is nothing but delta A vector. This is how we calculate dA. Same in cylindrical coordinate system. Whereas in Cartesian coordinate system, if this sphere is lying in Cartesian coordinate system and this is centered at the origin, then half of the mark, this is x-axis, where radius of the sphere A is above it and below it. X-axis, y-axis and z-axis. If that is the case, then we saw that I take any point x, y, z here, if it is centered at the origin, take any point x, y, z here, and then from origin draw a vector that is called position vector, xi plus yj plus zk. If that is the case, that is position vector, then dp by dx, if this is x-axis, this is xz plane. If this is y-axis, this is yz plane. At any point P, if I calculate dP by dx, dP by dx will move in xy plane, xz plane. dP by dy would move in yz plane. If I do cross of dP by dx and dP by dy, then it will give me the area underneath. Cross product will result into area vector also. So if that is okay, if that is the case, then we get area everywhere, and area vector will be parallel to perpendicular to the area. So there is no concept of delta A. Position vector dp by dx cross dp by dy, and then you remember that we talked, if I have a surface, if I have a surface and if I calculate the integration, it gives me volume under the surface. If I have a x-axis, if I have a line fx, then integration along x-axis gives me the area underneath. Now, if I have dp by dx cross dp by dy as area, that is velocity area, because p by x, it is velocity vector. So dp by dx cross dp by dy gives me the velocity area. If I have velocity area and I want the actual area vector, I have to do integration. If I want actual area, not the area vector, then velocity vector I have to calculate magnitude dp by dx cross dp by dy, calculate the magnitude and then integrate over xy plane, you will get the area. We calculated it. And if you have dp by dx cross dp by dy vector, and then you calculate, if this is the velocity area vector, if you integrate along xy plane, it will give you the actual area vector, dA vector. So that comes as minus dz by dxi minus dz by dyj plus k, and then dA, not a vector, dA. Now if dA, so in Cartesian coordinate dA, d of xy plane is dx dy, dx dy. So it is minus dz by dxi minus dz by dyj plus k, and then the dx dy. That is whole is area vector, dA vector. Whereas in a spherical coordinate system, whereas in a spherical coordinate system, if this is centered at the origin, and if I take half the mark, if I take half the mark xy plane, then if this sphere has radius a, then if I take half the mark, then radius a is above and radius a is below it. If I take a small height z, if I take a small height z, then at that z I make a delta a. One strip I can take it out, delta a. At height z from the xy plane at the equatorial, if I take height z, if z is a, then I reach the top. If I take a z height and there I make a small strip delta a here, then what is delta a? If there is an area, then it has two sides. One is vertical arc and one is horizontal arc. If you multiply, it becomes delta a. Vertical arc, if this is vertical and this is the radius, the radius of sphere, if this is vertical, radius is a. Now this is xy plane. Now a goes here. So it makes phi angle with the vertical. One thing. Second thing is, if I take z height, if I cut it here, it will make a cross section, that is another circle of radius r, that is smaller to r. If I cut at the equatorial center, then it will make a bigger circle of radius a, that is the radius of the sphere. At height z, if I cut, then there will be radius of a small r. Then capital A is the bigger radius, small r is the smaller radius. So we talked about it. Why I am giving this much explanation is, I have talked that this is $1 billion proof. This is not available anywhere else. What we are going to talk now. If this is the center, and this is height z, and then this is the actual radius of the sphere, and radius is like this. At height z, there is a smaller circle here with radius is r. If this becomes flat, then big circle at the equatorial of radius a, small a. If that is the case, then relationship is r equal to a square minus z square, z equal to a square minus r square. If this angle is phi, then a sin phi is r, a cos phi is z. These are the relationship. Now, if this is the equatorial plane, if it is xy plane, and this is A, if this is R, then R I can map along the xy plane also. If that is the case, then R cos theta is x, R sin theta is y. Means R equal to square root of x square plus y square. A equal to x square plus y square plus z square, square root. Okay, this is the relationship. Now we saw that if I have to calculate delta A in sphere at delta A, then one is horizontal arc, one is vertical arc. Vertical arc, if I say vertical arc and there is a phi angle here, and this is A is the radius, then A d phi is the vertical arc. Whereas if I talk about the horizontal arc, then it is r d theta. So r d theta, a d phi is the area. What about the unit vector? So this is the, if I take a small strip, if this is the sphere anywhere at height z from the center, if I take a small strip here, then from center, this is centered at the origin. From origin, if I draw a line, a vector at this point, then when it is touching this curvature, there is a radius a. Then along the radius a, that is the area vector. So area vector keep changing everywhere. So area vector is the along the radius. So what is the radius? Radius vector. So radius vector has I component, j component, k component. If I talk in a spherical coordinate system, then r unit vector. R unit vector, whatever it is, that is the area normal, area direction. But in xy coordinate, then if I take, so I can just say dA vector is nothing but r d theta a d phi. That is dA, and normal vector is r unit vector. That's it. Okay. Now question arising is that now someone is saying that was I doubt about dp by dx and dp by cross dp by dy, what you did in Cartesian coordinate system to calculate the d area. I don't understand. It means dp by dx cross dp by dy comes as minus dz by dx I minus dz by dy j plus k, and dxy plane, that is dx dy, that is dA vector, that is in Cartesian coordinate system. A spherical coordinate system is pretty straightforward. You take a delta A anywhere at height z, and then delta A, if at that moment the radius is r, then the horizontal arc is r d theta and vertical arc is a d phi, where it makes angle phi from the vertical. So that is dA, and r vector is coming out of radius, coming out of at that location, then r unit vector. So r d theta a d phi r unit vector is dA vector. Pretty straightforward. From here, can you bring back your minus dz by dxi minus dz by dyj plus k dx dy? Then I will feel very happy, because that is what I don't understand, dp by dx cross dp by dy, and then so many things. This proof is not available anywhere. So can, from the delta A concept that we see in a spherical coordinate system, from that concept, can I bring the Cartesian coordinate system from a spherical coordinate system dA vector that is brought through delta A concept, can I bring it back as primitive calculus through which we got the delta A vector in Cartesian coordinate? This is what the actual discussion is going on. Now, let's try. What is R unit vector? R unit vector, if I take R unit vector, then if I convert into Cartesian, now idea is, can I convert into Cartesian? So R unit vector, if I convert into Cartesian, it has I component, j component, k component. So if this is vertical and this is A and make it phi here, then vertical component is A cos phi. A cos phi. So A cos phi k. Now ith component is A sin phi. A sin phi is radius that will fall on xy plane, and that is the radius anywhere, xy plane. So if this is along x-axis, turn it. Now it will, that A sin phi will fall somewhere on the ground. Same thing what we are seeing here, r. So, and then r cos theta is the x-axis, r sin theta is y-axis, where r is a sin phi. So, a sin phi cos theta I plus a sin phi sin theta j plus a cos phi, a sin phi cos theta I plus a sin phi sin theta j plus a cos phi k. That is the r vector, not r unit vector. If I divide by its magnitude, it becomes the r unit vector. Then a term will go. Now it is sin phi cos theta I plus sin phi sin theta j plus cos phi k. That is the unit vector that turned from the r unit vector, and the dA, not dA vector. dA is r d theta a d phi. So can I convert it into minus dz by dxi minus dz by dyj plus k dx dy? This is $1 billion question. How someone can bring from a spherical coordinate system that has been brought through delta A fundamental, and from there someone can bring into the primitive calculus cross product arena. So now if I proceed now I have here, it is sin phi cos theta. So sin phi, if I take z height and this is a, then sin phi, if this is a, then this is r. So sin phi is r by a. Sin phi is r by a. Cos phi is z by a. So sin phi is r by a, and cos theta is x by r. So x by a. X by ai plus, now sin phi is r by a and sin theta is y by r, then it becomes y by a. X by ai plus y by a j plus cos phi k. Now cos phi is nothing but z by a. So z by a k. So x by ai plus y by aj plus z by a k, that came. And this side we have r d theta a d phi. Now consider that now we know y equal to r sin theta, y equal to r sin theta, dy equal to r cos theta d theta equal to dy by r cos theta. Now we have r d theta, so d theta turn up into dy by r cos theta, r gone, d theta by cos theta. Now here I have a d phi, a d phi. Now a d phi if I take then r equal to a sine phi. R equal to A sine phi. R equal to A sine phi. dr equal to A cos phi d phi. d phi equal to dr by A cos phi. A gone, d phi by cos phi. Now r d theta, A d phi becomes d theta by cos theta into dr by cos phi. Okay, so d theta by cos theta into d phi by dr by cos phi. Okay, now what is r? R equal to x square plus y square square root. What is r? R equal to, we have dy by cos theta into dr by cos phi. R equal to x square plus y square square root. Then dr equal to x by square root of x square plus y square, means x by r. So dr equal to dx into x by r. dr equal to x dx divided by r. I can replace there now, x dx divided by r. Cos phi is z by a. Now we have d theta by cos theta into x dx by r cos phi. Just leave it cos phi. Now what is cos theta? Cos theta is nothing but x by r. Cos theta is x by r. X by r, and there we have x by r, means r by x. There we have x by r, cut down, gone. So d theta, now we have dy dx divided by cos phi. dy dx divided by cos phi. Now cos phi is z by a. So z by a means a gone up, a by z, dx d by a by z. Now here we have x by a I plus y by a j plus z plus z by a k. Now here we have, okay, so x by ai plus y by aj plus z by ak, that side, and this side we have a by z. Now if I take a by z this side, it cut down everything and it becomes x by zi plus x by zi plus y by zj plus k. Z gone, plus k. Understandable, right? Plus k. Now we have brought up into that x by zi plus y by zk plus k. I mean x by zi plus y by zj plus k dx dy. The dx dy as per Cartesian coordinate, it is here also. But Cartesian coordinate is completely different. Minus dz by dx. Here we have x by z. Minus dz by dy. Here we have y by z. Plus k vector. Here we have k vector. Now x by z. What is x by z? What is z? If I see a sphere, then x square plus y square plus z square equal to a square. This proves that z equal to square root of a square minus x square minus y square. If that is the case, then what is dz by dx? Dz by dx is nothing but minus x divided by square root of a square minus x square minus y square if you do partial differentiation. So dz by dx is minus x divided by square root of a square minus x square minus y square. This is our proof. Please support. Our India country code is +91. Phone number is 948316061. This is telephone number +91 India country code, and then phone number 948316061. 1 0. Please support. Anyway, now we have x, y, z. Now here we have dz equal to minus x divided by square root of a square minus x square minus y square, that is dz by dx. Square root of a square minus x square minus y square is again z only. So dz by dx is nothing but minus xyz. Here we have xyzi that will turn up into minus dz by dxi plus yyz. Same thing, if I do dz by dy, it will turn up into minus y by square root of a square minus x square minus y square minus y by z. So minus y, so y by z will turn up into minus dz by dyj plus k. So it is sweep now. Now from the modern way through delta z that I calculated in a spherical coordinate system, that is sine phi cos theta I plus sine phi sine theta j plus cos phi k, and then r d theta a d phi, r d theta a d phi. If r is a sine phi, then it becomes a square sine phi d theta d phi. That is the full dA vector in the spherical coordinate system through delta A fundamental. From that fundamental, if I turn up into if I show the reality of the Cartesian coordinate system, I can bring back minus dz by dxi minus dz by dyj plus k vector and then dx dy. Can someone try now? Then if I have primitive way of calculating the dA vector, that is dp by dx cross dp by dy and dxy plane, that is dx dy, then can I bring into cylindrical coordinate systems? In cylindrical coordinate system, we also use the new way, delta A and then unit vector. I have done it. I believe 2 or 3 days back in that video, you will see this proof. Bringing primitive to new. Can someone type this primitive to new spherical coordinates? If already I have minus dz by dx I minus dz by dyj plus k and then dx dy, can someone convert it into spherical coordinate system sine phi cos theta I plus cos sine phi cos sine theta j plus cos phi k and then a square sine phi d theta d phi. So from older way to newer way, from newer way to older way we brought, someone can try. Hint is just try in reverse fashion. Whatever we tried, just try in reverse fashion, you will get it. So nice. So it is $1 billion proof that someone can actually get Cartesian coordinate dA vector from the delta A concept of integral calculus, that is calculated in a spherical coordinate system to Cartesian coordinate system. Mind blowing, you will never get anywhere else. This is our proof. And I have tired saying that we will file disclosure. There are, I believe, 50-60 items we have already in queue that we have invented. All things are new, that Lagrange variable, to so many things we have done our own. So our video is not what written in book, that we are just speaking in front of speaker. This is not the idea. Idea is to bring in new things so that it will be easy to understand. Things are easy to understand when you see the things from both sides. Okay, what is this? This is ball. I can see. You can see other side of it. I can see other side of it. What is this? This is ball. Keep it. No. What is this? This is ball only when you are certain, when you rotate and see other side also. So when you try to prove any fundamental, then you have to try both ways. Bottom side, if you're trying, then upper side, top side also you have to see. Left side, if you're trying, the right side also you have to see. Then only you can confirm that your algorithm is powerful or not. So that is the concept. So we were trying the kind of calculating the flux when the vector field is zk and it is hemisphere. Can we calculate? So vector field is zk and it is hemisphere. What is z in a spherical coordinate system? Z is nothing but a cos phi. Z is nothing but a cos phi. This is what we saw. So a cos phi and then whatever capital F vector dot dA vector integral over the surface. If there is a hemisphere kept and its radius is a, then what is the flux that is coming out of the hemisphere if the vector field is zk, zk dot dA vector. So in dA vector I have I component, j component, that gone. K component is cos phi k. Here zk, z cos phi, z cos phi, and dA vector is a square sin phi d theta d phi. If it is a hemisphere, then phi will go from 0 to pi by 2 and theta will go 0 to 2 pi. Now, if that is the scenario, then someone can try integration. So, integration is nothing but z cos phi a square sin phi d theta d phi. Z is a cos phi. So, a square a becomes a to the power 3. A to the power 3 I can keep outside. Now, it is cos square phi sin phi d theta. What is integration of cos square phi? If I do integration by part, then I can try integration by part is if I try integration of fx gx, then fx integration of gx minus big integration and derivative of fx integration of gx and then again integration. This is what it is. So cos square sin x, cos square phi sin phi integration will be cos square phi. I can keep outside. Integration of sin phi is minus cos phi. So minus cos to the power 3 phi minus big integration. Now integration differentiation of cos square phi to cos phi sin phi minus 2 cos phi sin phi. Integration of sin phi is minus cos phi, minus gone. Now it is 2 cos square phi sin phi and outside minus is there. So integration of cos square phi sin phi d phi. Same integration came what we are trying. If I take it left side, it becomes 3 integration of cos square phi sin phi equal to minus cos 3 cos to the power 3 phi. Then integration of cos square phi sin phi will become minus cos to the power 3 by 3. So here a to the power 3 double integration minus cos to the power 3 phi by 3. Now d phi we did the integration 0 to pi by 2. If I take cos pi by 2, it is 0, whereas 0 is 1 and 0 is lower limit, so it will be minus. Okay, so minus 1, minus gone, it is 1. At the end it is 1 by 3 and then 2 pi theta, 2 pi by 3 a to the power 3. Okay, so that is the flux that we can see through the hemisphere. If you are really very excited, then you can try through minus dz by dxi minus dz by dyj plus k and dx dy, where the vector field is zk. Who is stopping you? Okay, and the surface is hemisphere. Try it and we will see, probably we will enter into the flux density divergence. That is actual the concept of talking of the flux. So that we will see.